So as we move forward into more 3D shapes, the other thing we'll be asked to do is determine the volume of these 3D shapes. So when we talk about volume, volume is the measurement of how much space is inside a three-dimensional object. So this tells me how much an object can hold or contain, not how big it looks on the outside. So it's all about how much it can hold is the volume. So again, a simple definition for volume is the volume is the amount of space inside a 3D shape. Now, to do this, what you can think of is this. How many small cubes can fit inside an object? So the number of cubes it can hold actually represents its volume. Now, volume, we also have what's called the water bottle, but a lot of times water bottles volume is measured in like milliliters. Uh, Now, a milliliter is actually the same thing as a cubic centimeter, so we have some conversions we could do later. So a box's volume is kind of what we're going to get into more so. So again, a box's volume is how much you can put inside of it, how much cubic space it has, if you will. Or a room's volume, in other words, how much air is inside a room would be measured in cubic, if you will. So measurements of space, again, we talk about this cubic units. So the answers you'll be seeing in our work is cubic centimeters or centimeters cubed, if you will, cubic inches or uh, inches cubed, and cubic meters or meters cubed. So centimeters cubed means we have a cube that's 1 centimeter by 1 centimeter by 1 centimeter. That's its dimensions. A centimeter is basically the width of your pinky, if you will. An inch is again an inch. A cubic inch is like 1 inch by 1 inch by 1 inch. Now think of an inch like the width of your thumb. So from one side of your thumbnail to the other side of your thumbnail, that's approximately what an inch is. So notice that an inch is almost like double the size, maybe 2.5 times the size of your pinky, if you will. So depending on each other's fingers, but that's usually the estimate. A meter, basically is the distance off the floor up to a door handle. So notice that a cubic meter is a very, very big box. So if you think of that set thing, so 1 cubic meter is very, very big. So again, seeing these symbols here, that's what you're going to be using as your measurement for volume. So again, volume is a three-dimensional concept, so that's why we have the three here. So as we get into this, let's see if I can get this to work here. Oops, I think I've already opened it. So let's see here. So if we talk about volume, let's first talk out with like what we call a box, a rectangular prism. So a box is how many cubic cubes can be placed in it. So if we start out with an empty box, we can start putting cubes in. So this is a 1 by 1 by 1 cube. So if we go across here, notice how we got four across that way, another four across the bottom, and if we keep on going, another four across the bottom. So notice that the bottom is 12 cubics, but notice how we have to fill in the space with these cubes. So right now we have one column or one block of, if you will, of cubes here. So right now we've covered in 12 cubes in that space. So notice how we're now just going to be working vertically here. So this is going to be another 12. So it's 3 by 4, which is 12. So notice how 4 by 3, that's going to tell you how many cubes are in a block of cubes. Notice how we now have another block of cubes, but notice how we're now going vertically. So that's now 24. We now have 36. So like 48. And then So get that one more there. So notice how it's 60 cubics, if you will. Notice that our dimensions, we have this dimension here, 4 by 3 by 5. Notice that the 4 by 3 would determine how many cubes are on the bottom. And since it's going to be 5 cubes high, if you will, if you multiply those dimensions together, 4 times 3 would be 12, 12 times 5 would be 12 times 5 is actually 60. So we're starting to see that if I want to determine how many cubes are inside this, if I multiply the length times the width times the height, if you will, that'll determine the volume of the sphere. Now, I'm not going to go through all these shapes. We're just really just going to start focusing on the volume formulas. So let's just go back to our table here. So notice that the volume of a cube is going to be, since all the sides are the same, it's going to be s cubed. So remember, a side length is actually an edge, if you will. So the rectangular box knows how the length, the width, and the height is going to be, if we multiply those edges together, if you will, that will determine how many cubes are inside that box. A triangular prism, we start to get into what we call the space area times the height. So let's see if we have a triangular prism anywhere. See if we'll see if we come across any of those. So we have what's called a base area. So what we're saying is the base of the shape is a triangle, so we have to find the area of a triangle. Remember, the area of a triangle is actually this one half, the base times the height, if you will, where the base and height have to be, perpendicular to each other, if you recall. And then the height of the prism will tell us how. So once I find the area of the base, that tells me how many cubes are on the bottom, and then the height just starts stacking them up and how many stacks that we have. So remember, the height is actually going to count the stacks to get the total number of cubes inside the thing. So once we find the area of the base, that's going to tell us how many uh, are on the bottom, how many stacks of cubes are on the bottom. And then as we go up through the height, that's just going to count how many are in each one of those little block of stacks, if you will. A pyramid is going to be the space area times this height, but you actually have to take a third of that. So that's going to be the formula to find the volume of a pyramid. So now remember, the pyramid can have different shaped bases. So a pyramid could have a square base or a triangular base. So it can vary based on the pyramid. But once we find the area of the base, using the vertical height is going to tell us what we got going on there. But what happens is we have to take a third of that though, because a pyramid is actually like a third it only holds a third of what a rectangular prism would hold. So cylinder, again, we have this base area, which is pi r squared actually, times the height. So pi r squared is going to be the circular base, and then we multiply by the height to determine that. So again, the cylinder, again, this just tells you how much it holds, how many cubes it holds. But notice how this is going to be approximation because of the pi's approximated number. So a cone is going to be like a circle, but to find the volume of a cone, we have to take a third of the volume of a cylinder. So a cylinder, again, a cone is one third the volume of a cylinder with the same base and height. So notice that pi r squared h finds the volume of the cylinder, but we have to multiply by one third to get the volume of the cone because a cone is only one third the volume of the cylinder. So sphere has its own little formula. So 4/3 times pi r cubed is how we find the volume of a sphere. So again, if you need to pause the video each time or kind of rewind it a little bit, you can kind of rewind to catch things. So again, Volume is always measured in cubic units, cubic centimeters, cubic feet, cubic meters, if you will. Or again, sometimes I say centimeters cubed, feet cubed, and meters cubed. So we have a couple ways of saying that. And pi, we usually use 3.14 when we get into the curvature stuff, like the circles and the spheres and the cones. So again, cubic units in the metric system, we have what's called millimeters cubed, cubic centimeters, or we have a cubic meter. Those are the most common ones in the metric system. Notice how I mentioned earlier, 1 cubic centimeter is the same thing as 1 milliliter. So a milliliter is like a drop out of a one of those little eyedroppers. It's like a drop out of an eyedropper is what a milliliter is. It's pretty small. So cubic centimeter is not that big. If we talk about the customary system, again, we're talking inches cubed, feet cubed, and yards cubed if we're talking about our customary units of measurement. So again, volume is how much space something holds. So it's important, especially in packaging. Packaging would be really important for us in that sense. So again, liquid volumes, a lot of times we talk about milliliters and liters. So a lot of times in medicine, when they ask for volume, we're talking about milliliters. Soda bottles, we're talking about liters. So sometimes there's a reason to kind of go back and forth between like this cubic meter and milliliters. So there may be some times where we know the cubic centimeters, but we need to turn that into milliliters. So there's some conversions you may have to do. So some liquid measurements in our customary unit is we have fluid ounces, cup, pint, quarts, and gallons. Milk is the one I'm most familiar with because milk is sold by the gallon. A lot of times when it comes to fluid ounces, a lot of times we have 12 fluid ounces or 8 fluid ounces, you know. So 8 fluid ounces is actually a cup. That's the most common one. 8 fluid ounces is actually a cup. So we have that going on there with liquids. So again, medicines a lot of times are measured in milliliters. Water bottles are milliliters or liters, depending how big we are. Boxes, a lot of times we use cubic inches. A room is cubic feet. Swimming pools, like I said, if we watch the Olympics, we see that volume is a lot of times measured in cubic meters. Here in America, we have gas, not petrol. In other countries, gas is measured in liters, but here in America, our gas tanks, it's if you go to the gas station, it's measured by the gallon. So again, it'd be a good idea to pause the video and make sure you capture some of these formulas up here. Okay. And they're also in the textbook. So just keep that in mind. Okay. So when you see these formulas pop up, just pause and you can write those down. Alrighty. I think they started right here with cubes. So when you get to the spot, then you know you're getting into the formula spot. I will stop there. Best of luck with this assignment.